So now that we defined the concept of magnitude, let's apply that to stars of different distances. So we can define the apparent and the absolute magnitude. The apparent magnitude are the magnitudes that we observe in the sky. The absolute magnitudes would be the magnitude that a star would have if they were at a constant distance from us. Essentially, the absolute magnitude would be a measurement of the intrinsic brightness or the luminosity of the star. So because the flux depends on the distance following an inverse square law, the magnitudes that we measure are also a function of distance. So for this reason, let's call them apparent magnitudes. We can also define the absolute magnitude, which is independent of distance, and that would reflect the star's true brightness. For that, we'd need a standard distance. So let's call this standard distance big D. And for historical reasons, D was set at 10 parsecs. So you have that the absolute magnitude is the magnitude that you observe of the star at 10 parsecs. That's the flux that the star would have if observed 10 parsecs away. Now, notice that the difference between the apparent and the absolute magnitude is given by little m minus big M. It's minus 2.5 times the log of the ratio of the fluxes. And this is a quantity that depends only on the distance. Because it is little m minus big M, the apparent magnitude minus the absolute magnitude is also called the distance modulus. Now, because the flux follows an inverse square law, we can write these fluxes in terms of the square of the distance. So the distance modulus can be written as little m minus big M is equal to plus 2.5 times log the ratio of the distances squared, which is equal to 5 times the log of the ratio of the distances. And if the distance is given in parsecs, d is simply 10 parsecs, so that becomes 5 log d in parsecs minus 5. Now notice that because you can write the distance in terms of the parallax, you can express the absolute magnitude only in terms of observable quantities, the apparent magnitude and the parallax. You can also write the distance in parsecs in terms of the distance modulus. Both of these equations are quite handy.